Okay, number one, an electric bulb, blah, blah, blah. Can I have the answer, please? Eliska?
D.
D. Okay, good. D. Number two, Angeline?
B.
All right, number two is B for 16 cents. All right, so I think if you've done the exercises previously, you would already be okay with this. All right, next, number three, two filament balls, blah, blah, blah. Brandon?
C.
C, resistance of bulk P is lower than that of bulk Q. Okay, this is the one that we discussed the other day, right, Wilson? Do you know why already?
Tidak tahu.
Tidak tahu ah. Brandon, you want to explain to me why? Why is your answer C?
Because I calculate the resistance lah.
You calculate the resistance. Resistance of bulk P is lower than that of bulk Q. How do you count the resistance?
I use yang P equals to V squared over R.
Okay, V squared over R. So how much is the resistance of P?
P, I got 24.
Okay, 24 ohms. Really? 24? Okay, Q?
Q6, Yeah, Q6 ohm.
6 ohm.
6 ohm only.
Oh, 6 ohms.
For Q.
Okay. So, Wilson, in terms of calculation, this is the correct answer because the question says which is not true. But when I look at the other answers, okay, bulk Q is brighter than bulk P. We will remember the brightness is determined by the current. Okay, so if we use P equals to VI, okay, this one will give us 6 over 12, which is 0.5 amps. Okay, manakala this one will give us 2 amps. Okay, so this is correct. The current passing through bulk Q is bigger than the current passing through bulk P, which is also correct lah. This is 2 amps and this is 0.5 amps. Bulk Q produces more heat per second than bulk P. Okay, so this is the one that we were thinking of. I don't know whether it was you, Wilson, or whether we were thinking of this lah. Bulk Q produces more heat per second, okay, than bulk P. More heat per second means energy per second. Energy per second actually refers to power bahkan. And power is the amount of energy that is released or produced in 1 second. Remember the power rating? And 240 volts, 24 watts. It is the power rating. Okay, and so when we supply the same amount of voltage, we find that P produces less power, produces less heat per second than Q. And so Q is actually correct. Okay, so actually it has a little bit to do with the resistance, but if you take a look at just purely the power, Wilson, okay, this is 24 watts, means Q is producing 24 joules of energy per second. P is producing 6 joules of energy per second, which is definitely much less lah. So actually Q is also correct. Okay, so C is the only one that is not true, because when we calculate the resistance, we find that, oh, okay, resistance of P is higher, although the energy they are producing is much lower. Okay? Okay. Number 4. Damir.
A.
Sorry, what?
A.
Saya tidak dengar apa yang kau jawab.
A.
Oh, A. Okay, right. The answer is A. Yes. Speaking about this, okay, This is another question that actually only one person got this answer correct. The graph of was it V against T? I think it's V against T lah. Either that or pressure against temperature lah. Is this right? Okay. And then lepas itu ramai yang tulis di sana directly proportional. Okay. Guys, be very careful lah. For Charles' law and for pressure law, okay, it is directly proportional to absolute temperature. Okay, absolute temperature is temperature that is counted now in Kelvin. Okay, if it is degrees Celsius, okay, then it is increasing linearly. Okay, but if our temperature is in Kelvin, which is the absolute temperature, then you will get a directly proportional graph. So I think only one or two people got this question correct. Okay, it is designed purposely to trick you all. All right, number 5. Daniel?
D.
D. The rate of change of current is 60 watts. Huh. No lah. Okay, it cannot be current. It is definitely with energy. Remember, power is energy per second. Okay, so it has to be the rate of change of energy because this is the formula for power. Okay, if you want the rate of change of current, you're talking about there's nothing that has to do with rate of change of current. Tiada apa-apa ni. Okay, only energy. Okay, it's 60 watts. All right, number 6, Elijah.
C.
C. Hold on. This question is giving me number 7 first, but okay, fine. Number 6 is C. All right, number 8. Number 7 is D. Sorry, I don't know what's wrong with this slide. Number 8, Isabella. Okay, fine. The answer is A. Okay, I hope you said A lah. Okay, because I really couldn't hear what you said. I don't think something is wrong with my ear. Okay, let's go to question number 8. We're gonna start with who's after Isabella? Jacinta. Okay. Answer for 2, please. Why did they skip 1? Okay, fine. If the cost of electrical energy is 20 cents per unit, calculate the cost of electric stove for 30 days.
60 ringgit.
60 ringgit. How do you get 60 ringgit?
Jam number 2 kan yang 20 sen tu kan?
Ya, ini.
300 kilowatt per hour times 0.20.
Okay, how do you get 300 kilowatt? Actually, it's not kilowatt per hour, it's kilowatt hour. That's how we pronounce it.
Tu na yang number 3 tu dia cakap 5 hours per day, 2 times 5 equals to 10 kilowatt hour, and then 10 times 30 equals to 300.
Oh my goodness, this question is all over the place. Okay, sorry. Okay, so this one is over here. Okay, calculate the energy in 30 days, and then after that, the cost is over here, which is was it 60 ringgit that you got just okay, 60 ringgit sorry everyone.
Yeah.
Astaga, apa ini? Okay, 60 ringgit the final answer 60 ringgit. This one is 300 kilowatt hour. Okay. One important thing to remember is that when you count, bila kita cakap pasal duit makan, okay, we need to know that our power is counted in kilowatts. Okay, so the energy is kilowatt hour. Okay, it's the only situation where you have to change the unit once again. Just like the heat question, makan, Charles and pressure law, you have to change the unit to temperature to Kelvin. Okay, so this is the exact same case that they change the unit. All right, thank you. Number 4. Let's take a look at this one. PQRS. Tell me each one. Structure of wire, which one is good? Type of wire, which one is good? Cross-sectional wire, which one is good? Jericho.
Coiled wire.
Okay, coiled wire. Why coiled wire?
Has high resistance.
Okay, good, high resistance. Crispia, type of wire, please.
Nichrome.
Why nichrome?
High resistance.
high resistance, okay, and also high melting point. These are very standard answers, people. Okay, these are very standard answers. Why we use coiled wire? Because the longer the wire, the more the resistance. So we want more resistance because the question is asking for us to make a heating element pemanas. The most important thing is dia mesti panas, bukan terang. Okay, kita mau elemen pemanas. We want the heat. Okay, so type of wire will be nichrome because it is a high resistance. Another good answer will be high melting point. Lester, cross-sectional area, please.
Small cross-sectional area.
Okay, why?
High resistance.
Same thing, high resistance. After a while, you find that actually electricity questions, if in these terms, right? Okay, everything also you can give the same reason. High resistance, high resistance, high resistance. You just have to remember what are the situations that cause high resistance. Okay, so based on this answer, which is the best suitable heating element? Louis?
S.
Okay, very good. S. Next, Michelle, state the physical quantity measured by the voltmeter.
Electromotive force.
Really? Sorry, really? No lah. Hold on now. The switch is on or this current is flowing. It cannot be electromotive force.
Voltage?
Yeah, okay, voltage or potential difference. If the current is switched off, guys, then it is electromotive force. Okay, electromotive force is the potential difference reading when there is no current. But currently, okay, there's a pun over there, fine. Currently, there is a current flowing over here. So please know that this is voltage, potential difference, okay? All right, calculate the resistance of the bulb. Mordecai?
14 ohms.
Okay, 14 ohms, it's quite easy lah. Use the ohms formula to do this. Okay, Iqbal, you want to try number 2?
168 joule.
Very good. Okay, 168 joules. We find various ways to count the power. The easiest way, obviously, is to use V and I lah. Okay, since it's given V and I. But you calculated R also, so you can also use the same thing if you want. But you will still get 168 joules. Okay, very good. Next, Shim. This is not a question. Okay, shape of wire. Sorry, what are we doing? Oh, electric irons and... Okay, so it's either coiled or straight.
Coil.
Okay, coil. Why coil? So boring.
Increased length.
Okay, increased length also good. Increased length can, but you need to finish it lah. Increase length by increasing the resistance. That's the ultimate goal lah. Okay, yeah, so think of that lah. Okay, so you see guys, after a while kan the question is like, ini saja dia punya soalan ni. That's why electricity is easy but also difficult lah. Okay, astaga, saya pergi bagi jawapan sudah. But okay, tidak apalah. Nichrome. Okay, again the same thing. Why nichrome? Because it's high resistance. So boring already. Why you ask us this thing so many times? Okay, suitable fuse. Suitable fuse, please, Rania.
5A.
5 ampere. Why 5
ampere? I write more current flow which causes more heat.
Low current flow which causes low heat. Okay.
No, more current flow which causes more heat.
More current flow which causes more heat. Okay. I think that's a good try. It's not entirely correct, but we can learn from there lah. The first thing we need to understand is what is the purpose of the fuse. Okay. Let me go back to this. Adakah? Oh no, that is not given. Okay. So the fuse. The fuse is a thing inside your 3-pin plug. Hold on, let me see if I can find it. So this is what a fuse looks like lah. Okay. So this is what I don't know if you can see. Okay, this is what a fuse looks like, and on the fuse, they always write the current over there. Okay, so in this particular fuse is 13 amps. Okay, sorry, I don't think you can see this. Okay, this 13 amps. Okay, 13 amps, and the fuse is located in your 3-pin plug over here, right? Okay, the fuse is located. Okay, this is where all the wires go lah. Okay, so this is the earth wire. The earth wire, this is the neutral wire, this is the live wire. Okay, so where the live wire is where the current flows in lah. Okay, if I'm not mistaken. Okay, if there's any electrician watching this video, please correct me if I'm wrong. Okay, but the basic purpose of the fuse is that the fuse is meant to cut the current, stop the current flow if it detects a current that is more than what it can take. Okay, so as I said just now, in this particular fuse, it is 13 amps. So that means if more than 13 amps of current flows into the plug, okay, the fuse will automatically break. It is just a piece of wire actually. If you open this plastic, you open inside, you actually look at, actually it's just a piece of wire. Okay, it's just a piece of wire that if more than 13 amps, kalau ini adalah 13 amps lah, if more than 13 amps flow into the fuse, through the fuse will break and it will not allow the current to flow through. Okay, and that means its role, dia punya peranan ni sangat penting tau, untuk memastikan bahawa your current flow doesn't exceed the limit. Because if it exceeds the limit, it's going to make your perkakas electric rosak. Okay, so you want to find a suitable fuse that can allow the current to flow, but it cannot allow too big of a current to flow. Okay, so when we calculate this, when we go back to this, okay, if we go back to this, we find that we need to know how much is the current flow over here. Okay, so if we use the formula P equals to VI, our power is 1000, volt is 240. So how much current is going to flow when we supply this?
4.167.
4.16, okay, 4.16 amps about. So a suitable one will be 5 amps lah. Definitely not 4 amps, because if 4 amps is flowing and our this one is 4.16, sorry, if 4.16 amps is flowing and our fuse is only 4 amps, dia sudah melebihi kita punya had. Ini adalah had kita. Okay, so definitely the moment you turn on this model, it will immediately putus. Okay, you will hear a very big explosion, begitu, because the fuse putus already, because you provide too much current to the fuse. So you need 5 amps. Okay, so siapa yang jawab tadi tu? Rania. Okay, Rania was answering it correct lah. Okay, it's 5 amps, but the reason it will be like this lah. Okay, the value needs to be a bit higher than the current flow in the circuit. The current flow in the circuit is 4.16 amps because we are supplying 1000 watts of power and 240 volts of voltage. So the current flow is 4.16 amp. So the value of the fuse must be a little bit higher than the current flow in the circuit. Okay, a very common question that is asked in this, dia akan bagi begini tau, 4 amps, 5 amps, 6 amps, and 7 amps. And then they ask you to choose one. Kalau the current flow is 4.16, which fuse yang sesuai, 4, 5, 6, or 7? The answer will still be 5. It cannot be 6 and it cannot be 7 because too much current flow will cause the iron to be rosak. Okay, or the perkakas electric lah. Remember that power rating, okay, the reason why electric instruments must have power rating is so that you know how much current needs to flow so that it will operate normally. You provide too much current, it will overwork. You provide too little current, it will underwork. Okay, just like the brightness question just now, okay, you will always find that how much current it is so that the bulb can light up with normal brightness. Okay, normal brightness is the current that is the most suitable, okay, for it to function properly. So in this case, the most suitable current is 4.16 amps. And so you don't want a situation where you have a 6 amp or a 7 amp fuse. Walaupun dia lebih daripada 4.16 amp, but if your heart is 6 and 7, you can still provide, say for example, you can still provide 5 amps or 5.5 amps of current. Okay, and the iron will still function, but it won't be able to function normally. It will over-function. Okay, just like just like giving too much homework science stream students, okay? You can tahan, but if you give too much homework, then you just over-function, okay? So it's not always a good thing. Okay, says the teacher who always gives so much homework. Okay, so the best one will be R lah. Okay, this one is Shim. The question is here pula kan, not actually in 3.2.
Also got at 3.2.
Kan also but at 3.2, right? But it's actually the same question, kan?
Yeah.
Yeah, so yeah, okay, so anyway, this question is also at 3.2, and I thought that they wouldn't ask it at 3.4 because when I look at it, it's a 3.4 question. I also don't know why. Okay, let's talk about the characteristics. This is a 10-mark question, so you know that you have to answer in the table. But never mind, let's figure it out. Wire. Okay, let's talk about the type of wire, please. There are two types of wire, tungsten or copper. Tian.
Tungsten.
Why tungsten?
High melting point.
Okay, high melting point or?
Produce more heat.
Or?
High cool. High heat energy.
Tian, you're refusing to use the word that I like to use.
High resistance.
High resistance. High melting point, high heat energy, high heat produce. High resistance, okay? All right, next, thin or thick? Valerisa.
Thin.
Thin, why thin?
More resistant.
Okay, high resistance. Okay, Tian. Oh, saya sangat terhibur lah, Tian. Okay, coil or not coil? Wilson.
Coil.
Why
High
coil?
resistance.
Okay, high resistance. Not high heat, man, or high heat energy. Okay, this is the good question. Low pressure or high pressure, Wilson? Sorry?
I think it's high pressure.
High pressure. Why high pressure?
I don't know.
Okay, fine. Okay, we'll answer in a while. Coil, definitely. Okay, long wire, more heat, high resistance. So looks like Tian is not the only one that put high resistance last. Okay, thin, so there is high resistance, more heat, tungsten, high melting point. Okay, so now we come to the gas lah. Okay, think about it guys. In a normal situation would you prefer gas with low pressure or high pressure? What happens in low pressure gas? What happens in high pressure gas? Okay, if we think about it logically, we need to choose low pressure gas so that the bulb will not explode. Okay, high pressure and heat is not a very good combination. Okay, high pressure and heat, because remember, the bulb is producing a lot of heat by the resistance from the wire. So if you put that heat inside the gas of high pressure, you're basically creating a mini bomb. Okay, so you want to put low pressure gas so that the bulb will not explode after it lights up a long time. The question that you should be asking is, why do we even want this nitrogen gas inside? This is my question actually. Have you ever thought of this? Kenapa kita mau ini nitrogen gas di dalam mentol itu? Okay, go and research this. This is a good thing to research. Okay, go and ask Mr. Google or Mr. Electrician. Okay, why is it that we must have nitrogen gas inside the light bulb? Okay, I bet some of you may have asked this but I bet most of you may have just focused on high pressure, low pressure, but you never asked the more important question. The more important question is, why do we want the nitrogen gas inside? Why not oxygen? Why not hydrogen? Why not helium? Okay, why nitrogen gas? Why must there be nitrogen gas inside the light bulb? Okay, maybe Wilson, you can Google this and you can share with us the answer. Okay, but anyway, we will use low pressure gas so that the bulb will not explode. Okay, and so the best one will be to choose R. Okay, this is where things get interesting. Now we want an incubator. Okay, we want an incubator, satu tempat untuk mengeram telur lah, menetaskan telur, fine. Okay, so the temperature must be maintained at 39 degrees Celsius. Every part of the eggs must receive uniform heat. The eggs are hatched in about 20 days. Okay, all these are important information. So let's talk about the modifications that we can do to efficiently hatch about 200 eggs. Okay, think about everything that you've done. What kind of modification can be done?
Bigger bulb.
Okay, I'm just gonna list it down here first. Bigger bulb. Okay. Why bigger bulb? Why a bigger bulb?
Because we produce higher heat energy.
Okay, so one of the important, thank you. One of the important things that we want to do is to produce more heat, because we now have 200 eggs that we want to hatch. Thanks, Adam. So we want to produce more heat. So this is kind of one of the big reasons for this modification, because currently currently it can only do 1, 2, 3, 4, 5. Okay, so we need to somehow modify this design. I'm not giving you the answers directly yet. We need to modify this design. There are many ways to modify this design, but the purpose must be the same. It must be maintained at 39 degrees Celsius, and it must be able to hatch 200 eggs, and they must be able to receive the heat uniformly. Okay, don't think about the answers yet. Think about what you can do. Think about what you should do, okay, to this one. So bigger bulb. I'm going to get suggestions from everyone. Brandon, sorry. Oh, Eliska is gone. Brandon?
Thicken the wall.
Thicken the wall. Okay, why?
To avoid heat loss.
To avoid heat loss. Okay. How would you make the wall thicker?
Letak yang telur-telurnya.
Letak tu telur-telur. Oh, so letak tray telur di tempat kamu mau menetas telur. Okay, boleh. Alright, next, Damir.
Using fan.
Fan? Okay, I want to know why fan though. Kenapa fan?
It can distribute uniformly.
Okay, distribute uniformly. This is interesting. Okay, next person. Daniel.
Increase the size of the incubator.
Increase the size of the incubator. I think so far this is a very good suggestion. Okay. Why do you think we need to increase the size, Daniel?
For the 200 eggs.
Yeah, okay, exactly. This is the first question. This is the first issue that needs to be solved, 200 eggs is no joke, guys. Okay. You want to carry 10 eggs in one hand also already so susah. This is 200 eggs in one incubator. Okay, so you need to modify this incubator so that it increases in size. Okay, don't limit yourself to just electricity. Okay, be more open. This is heat, electricity. It can even be maths. It can even be RBT also if you want. Okay, next person, Elijah. Elijah ni sama dengar. Mesti dia punya jawapan kreatif ni kan.
Parallel circuit.
Parallel circuit for what?
One bulb damage, another bulb still can function. The heat can be distributed uniformly.
Okay. Wow, this is interesting. Parallel circuit. In order to have a parallel circuit, there is one thing that needs to be done. Let me see. Irina, what can you suggest? Right now, I don't have a parallel circuit in this current incubator. If I want to have a parallel circuit, like Elijah suggests, what must I do?
Add more balls?
Yeah. Okay, exactly. You need to increase the number of bulbs. How can okay, so this is an important thing that we need to see, guys. This is only one light bulb for 5 eggs, 200 eggs, people. Okay, so obviously we need to increase the number of bulbs, and then we can use Elijah's idea, which is to put the bulbs in a parallel circuit. Okay, there is more than 5 answers here, guys. I can think of at least 12 answers. Okay, of course we are tied down. Kita hanya terikat kepada 5 cadangan but there are at least 12 ways that I can think of. Okay, to modify this incubator so that it can fulfill 39 degrees Celsius, 200 eggs, uniform heat. Kita belum lagi cakap pasal 20 days ini okay. Jacinta, give me one last suggestion. There are many suggestions Just ask for one more
Multi-story rack.
Multi-story rack, okay. Multi-story means dia adalah satu rak yang bertingkat-tingkat. Okay, why multi-story rack?
More eggs can be arranged.
Okay, more eggs can be arranged. So instead of having just one layer of eggs, 200 semuanya, you have many layers of eggs. But in order to do a multi-story rack, this is where the parallel circuit comes in. Okay, so every rack, setiap baris pada rack itu will have the light bulbs lah. Okay, I'm going to stop here. Thanks for your ideas, everyone. There are many more ideas lah, but we'll stop here. Okay, the first one is use the fan, which is, I don't know who suggested this. Okay, to ensure, I think Damir, to ensure every egg received will have uniform heat. This is a standard answer lah. Okay, now something that I think nobody noticed now was this next one, which was use a thermometer or thermostat. Remember the question? It needs to maintain at 39 degrees Celsius. How do you maintain the 39 degrees Celsius is you add a thermometer or thermostat so that you can control the temperature. Okay, if you see that, dia lebih daripada 39 sudah, then you need to reduce the number of bulbs that are being this one. Okay. Another one which I also didn't see, but I think Brandon had an idea lah, cuma dia tidak kesampaian di sana, which was to use a heat insulator, wrap the egg. Okay, put the egg. Sebab kamu mau mengeram itu telur, mana ada ibu ayam kan yang mengeram itu telur kan dengan berdiri, tidak. Okay, the mother, the hen, okay, the ibu ayam kan sentiasa membekalkan haba yang konsisten. Okay, by sitting on top of the eggs lah. So if we think about it, we need to either wrap the egg or we use the heat insulator, atau if we use Brandon's idea, guna tray telur lah. We use the egg tray, put the eggs on the egg tray, okay, so that we can prevent the heat loss. It was a good idea actually untuk letak tray telur, tapi dia punya idea adalah letak tray telur di keliling di keliling kotak lah. Okay, which is to control the temperature. Also can, but the best way is you control the temperature by moving closer to the egg. Okay, so you use a heat insulator, kamu balut. I mean, if you kalau banyak duit, then setiap satu itu kau balut pakai kain lah, kain sutra, kain apa-apa lah. Okay, but most basic can be the egg tray lah. Okay, because we want to prevent the heat loss, and so that we can maintain the temperature at 39 degrees Celsius. Okay, another one is also, I didn't see this, we use a shiny or silver material or mirror. Okay, because mirror is good, it can reflect the heat around. So you don't have to waste too much energy. Okay, you don't waste too much energy by providing, electrical current. You use the power of the mirror. Remember your solar oven last year, guys? You use mirror lah and don't know what lah, aluminium foil lah kan to reflect the heat. Okay, even though some of you until night time or so you still want to fry the egg lah, so don't know what happened. Okay, this was the suggestion by Elijah. Bulb arranged in parallel circuit, and you can provide heat continuously even if one bulb burned out. Okay, this is a good one. And this one is Jacinta's idea. Arrange the egg in multi-story racks. Okay, so you can accommodate 200 eggs. There are more suggestions actually than just daripada ini 5 sahajalah. Okay, there are way more suggestions which some of you gave. For example, okay, this one, increase the number of light bulbs. It's not mentioned in there, but I would accept this. Increase the size of the incubator. Also an important, this one, not mentioned in the answer scheme. Does it mean the increased size is wrong? No, it is correct. Okay, it is correct because you are modifying apa yang sedia ada untuk menjadi benda yang baru. Now, I am very emphasizing this kind of questions daripada yang setakat memilih yang terbaik because this is a section C paper 2 question. Section C paper 2 question, you have no choice. Kamu mesti jawab soalan itu. So mau tidak mau bahkan soalan modification, kita tidak boleh ramal. We cannot predict apa yang keluar, apa yang tidak keluar. So we have to be ready for whatever question comes. The more creative you are, the more you are able to think outside the box, the better you will be at answering these questions. All right? Okay, let's continue. Oh dear. Do we want to do this? Okay lah. What is the meaning of power? I'm going to go straight into this. This is power is energy over time. Okay, rate of work done, rate of change of energy also can. Okay, two identical bulbs are connected in a circuit shown as this one. If another identical bulb connected XY parallel to bulb P, means soalannya adalah cakap kalau saya letak satu lagi bulb di sini. Okay, explain what happens to the reading of the ammeter and the voltmeter. Jericho.
Ammeter reading increases and the voltmeter reading decreases.
Okay, ammeter reading increases, voltmeter reading decreases. Can you tell me why the ammeter reading increases?
Sebab dia punya resistance meningkat.
Resistance meningkat, so current pun meningkat. Are you sure?
Resistance dia decrease.
Yeah, okay, resistance decrease. I'm going to up your answer a little bit. We don't say resistance, we say effective resistance. Astaga, kejap. Okay, we say effective resistance decrease. Okay, and just like Jericho said just now, voltmeter reading decrease, and the answer is the same lah, because the effective resistance between X and Y also decreases. Okay, walaupun the voltage across Q, will increase. Okay, so here the voltage will increase, but over here the voltmeter reading will decrease. Because when you add more bulbs, when you add more resistors in parallel, okay, the sorry, the voltmeter reading over here, okay, will decrease. All right. Is this the last one? Oh no, it's not the last one. Okay, calculate the total resistance of one bulb, please. Next person, Lester.
2 ohms.
Sorry, how much?
2
Okay, never mind, 2 ohms. Okay, total resistance in the circuit, Michelle?
0.67 ohms.
0.67 ohms. I guess you are right. Okay, good. Total energy dissipated by the bulbs in 2 minutes. After Michelle is who? Mordecai. Yeah, Mordecai.
1,480.
Okay, 6,480 joules. Okay, use the sorry, count the energy and then times 2 minutes times 60. Okay, this 3 times 18 is given over here. All right, let's go to this one. Last question. This should be the last question. Is this the last question? Hold on, let me see. Is this the last question? Yes, it is the last question. Okay, this is membuat pilihan lah. It's a section B question, so it's a little bit relaxed. Okay, let's talk about the heating element. Nichrome or Constantan? Oswald, do you think you can try this?
Nichrome.
Nichrome. Why nichrome?
High resistant.
Okay. One thing you should take back with you, Oswald, is that whatever it is, nichrome, tungsten, okay, has high resistance. Constantan is low resistance. Okay, good. So we want to use nichrome. Okay, wire, thin or thick? You see the difference over here, right? Thin wire and thick wire. Okay, which one do we want? Shim.
Thin wire.
Thin wire. Why thin wire?
High resistance.
Okay, high resistance. After a while, this question gets very boring already, right? Okay, third one is the power of the fan. So this is 1,000. No, sorry. Power of the fan is this one. 60, 40, 80, 100. Which one? Astaga, what did I do? My goodness. Okay, sorry. Which one would it be best? After Shim is who? Tian.
Power often bigger. I mean,
okay.
Larger. Yeah.
All right, bigger power. Remember, guys, even if the answer gives you 60, 40, 80, 100, you don't say the number. Say bigger power. Why bigger power, Tian?
High resistance. Produce more heat.
Cannot. Tian, of all the people in this class, even I that don't have rambut also, I know why we must have a bigger power fan, you know. Think of the hairdryer you use in your house. 怎么你要那个大的 power 的 fan?
Faster. I mean, faster.
Yeah. Faster what?
Faster, like More heat to produce faster.
Okay, more heat produced faster. Okay, this one we have to fix lah. But come on lah, guys. Sometimes the answer you use everyday one, you know. 我没有头发，我也是知道的。So you also must know. Okay, saya kena rambut pun saya tahu. Kenapa kipas kan mesti kuasa tinggi? Why must it be bigger power? Okay, alright. Sorry no much time. But this is a good question because the last one is the fuse. Rania, it's you again and the fuse. Why? What fuse do we use?
5 ampere.
5 ampere. Why 5 ampere? This one, okay, sorry, wait. Wait. Okay, guys, this one, kalau fuse, we have to make an exception. We cannot say bigger fuse, smaller fuse. Okay, because fuse is very specific. Okay, why 5 ampere, Rania?
Because the value has to be higher than the current flow in the circuit.
How much is the current flow in the circuit?
The current flow in the circuit is 4.5.
Okay, 4.5 amps. So it has to be more than 4.5 amps, but cannot be too much. So 8 is already too much, 10 is already too much, 3 is too little. So this is like Goldilocks and the Three Bears, if you know that story, kan? Just nice, 5 amps. Okay, so take a look at this, guys. The power of the fan, is only 80 watts. This is a better power. Okay, this is a better power, 100 watts, but it doesn't fit the criteria. Okay, that's why for things like power, okay, we have to play it safe, you know. Kalau kamu jawab 100 bahkan, then you are stuck, you know, because you have to choose this fan. Padahal this is the fan that you want. Okay, that's why we say bigger power. But for fuse, we have to mention, okay, because we are calculating the current flow inside. Wow, it's amazing that Rania is the one that got this question. Padahal tadi pun kamu kan. Okay, after 10 is who? Wilson. Wilson, what is the best? No, Valerisa. What is the best?
Hair dryer tea.
Okay, hair dryer tea. Macam Valerisa selalu dia kena pilih saja kan. Terus the next person tiada sedar. Okay, so hair dryer tea is the best lah. Okay, for all these reasons. This high power of fan, Tian, we will say blow more hot air lah. Okay, because the purpose of the fan is to blow the hot air towards us. Okay, all right, that's it everyone for today, and that's it for this chapter.